Welcome back to Securing Cyberspace. We are right in the series of Kubernetes security, and in the last two episodes we talked about first challenges of Kubernetes security and about some tools who are helping securing the Kubernetes clusters. And in the end, Bastian Hofmann, who is also attending me today, is talked about NeuVector or Open Zero Trust. And today we want to introduce this very complex tool and how your cluster can be secured. Welcome back, Bastian, and start with NeuVector.
So now let's look a bit deeper into one tool that can help you to protect your supply chain, but also your Kubernetes clusters at runtime, which is NeuVector. And the reason why I'm talking about NeuVector is, one, it's a product from SUSE, but B, and most importantly, it's also open source. So you can just directly start and try it out. And in 5 minutes or maybe an hour, make your clusters a lot more secure. NeuVector is handling security on two levels. First is the supply chain. This is all about scanning your container images for known security vulnerabilities, for compliance issues. And the second one is the runtime security, protecting your containers, protecting your applications against security vulnerabilities and CVEs that you either know or don't know about. Let's look at this more deeply and let's look at the supply chain security first. A typical supply chain of a containerized application looks somehow like this. A developer writes some code, and when they are happy, commits the code to a version control system, for example, Git repository. Then there is some CI/CD pipeline and some tool starting to run, executing some tests, and at some point building a container image. And this is the first interaction point where you can integrate NeuVector. You can integrate NeuVector into your CI/CD pipeline, scan the currently built container image for compliance issues or security vulnerabilities, and then decide what you want to do with the result. Do you want to fail the build, for example, if NeuVector found a CVE? When everything is okay and the build passes, the image is pushed to some kind of private or public container registry. And also there, NeuVector can be integrated, and you can scan all the registries that you have continuously, all the images in there for compliance issues or security vulnerabilities. At some point, you want to deploy your container image to production or to a staging cluster, to some Kubernetes cluster. There is an admission control system in Kubernetes we talked about earlier. And in this admission control system, NeuVector can also hook in. So you can, for example, configure admission control rules inside of NeuVector to tell Kubernetes, hey, if there is now a new deployment that is being deployed with a container image that already has known security vulnerabilities, block the deployment. Or you can make it more complex and say, okay, block the deployment if there are CVEs in the container image with a severity of minimum high and that are older than 5 days and that already have a security patch for it. Because if there's no patch for it, or if it's like a very young CVE, or if it's a medium severity CVE, maybe you don't want to block the deployment, you only want to alert. And last, at some point your application is running inside of the cluster, and then also NeuVector can continuously scan all the running containers and container images for vulnerabilities that pop up over time, so that you then get an alert and know, I have to patch, I have to update something because something is happening in production. And this is a lot of tools do that actually, all the scanning part. And we even covered in the iteration before, in the video before, we covered some of the tools that do registry scanning, that do CI/CD scanning. This is not something that is specifically unique to NeuVector. What makes NeuVector unique there is that it's a very fast and accurate scanner, and it's very scalable. So you can easily scan hundreds or thousands of images very quickly. It is also very easy to set up in an air-gapped environment where you have to run everything on premise without any internet connection. And it's Kubernetes native, so it's very easy to deploy and run and upgrade and configure. It's in the end just a Helm chart. And scanning images is important. You will need to know how bad your security currently is, how many vulnerabilities do you have in order to actually do something about this and create a strategy to fix stuff and upgrade stuff and patch stuff. But it's also definitely not enough, because it could be that you're running something in production already and then a CVE is announced, probably on a Saturday night, and it takes you 1, 2, 3 days to actually update something. Maybe the colleagues that work on these services are currently on vacation or sick and nobody dares to touch them. The services, I mean, not the colleagues. And then it maybe takes 1 or 2 weeks to update something. Maybe there is a CVE announced, but there is no patch yet. Or maybe you can't update to the patch because first you have to update your code to work with a new library version. Or maybe it's a CVE that hasn't even been announced yet, but it's already attacked in the wild. Or maybe it's actually not a CVE that's published, but like there is a bug in your software that you've wrote, in the code that you've wrote, that is actively being exploited. And no CVE scanner in the world will be able to find that. So you also have to protect against things during runtime, and you have to protect against vulnerabilities that you know and that you don't know about. So let's look at runtime security. Runtime security, as I said, you can protect against things you know with threat-based controls, or against things that you don't know with zero trust controls. Threat-based controls are protections against CVEs and known network attacks, things like SQL injection, cross-site scripting, some TCP buffer overflow attacks, things like that, where you can then, for example, configure a web application firewall or data loss prevention systems to scan all your traffic, detect these attacks, and then block traffic. The zero trust controls work differently. There, you can look at all the processes that are being executed in your system and in your containers, at all the network connections that are being made, at all the files that are being accessed, and then only allow the things that are necessary for the application and block everything else. And in NeuVector, you can do this, and you can also automatically learn all these rules for network connections, process execution, and file access, and you can also then transport them between clusters as security as code. Let's see how NeuVector does this. Here you can see a typical Kubernetes cluster. Of course, it's a bit simplified. We have 2 pods, and each pod has 3 containers, and everything communicates with each other. You have the so-called east-west traffic. That is the traffic between the containers within a pod, between the pods inside of the cluster. And you have the so-called north-south traffic, which means traffic from the outside that goes into the cluster to some pods, and traffic from the pods that goes to the outside, the internet or intranet to external services again. And NeuVector can see all these connections and protect them. And what's unique about NeuVector is that it's not only seeing who connects to whom, but it's also doing a deep packet inspection directly on the network stack at the source before it reaches your applications and containers, and protects then this connection on layer 3 and 4, who connects to whom, but also on layer 7, what is actually spoken on this connection. So let's, for example, say the pod on the left is a WordPress pod, the pod on the right is a MySQL pod. And first of all, NeuVector can then restrict the WordPress pod to only have outgoing connections to the MySQL pod and to nowhere else. And it can restrict the connection to only speak the MySQL protocol and nothing else. You can also restrict which processes are being executed in the containers. So for example, in the MySQL container, you should only execute the MySQL daemon and nothing else. And this deep packet inspection allows then not only to restrict which protocol is being spoken upon, but also to configure web application firewall rules to detect known network attacks or data loss prevention rules to restrict and detect, for example, if credit card data or social security numbers leave your system. It's also through that the possibility for you to really protect yourself against unknown CVEs of 0 days or things that you can't patch. Because even if an attacker can get into your WordPress pod through, for example, some broken plugin. They may be inside of the container, but they can't do anything. They can't connect to their own server to download additional binaries or scripts. The network connection is blocked. They can't connect to their own server to maybe transport data or leak data to their own servers and send them back because the connection is blocked. Even if the connection were possible, if they download something like some script or some binary, it's not allowed to be saved inside of the container image. And even if it's allowed to be saved, they can't execute it because it's not in the whitelist of processes that are allowed. Also, these layered attacks, where maybe an attacker gets into one application and then finds a vulnerability in another application and a vulnerability in another application, and at some point they get privileged access, are also not possible because the WordPress pod is only allowed to connect to MySQL and to nothing else. And what you can...
Sorry, I don't want to interrupt you, but I don't want to interrupt you. Okay. I just asked myself, how do you define these rules for NeuVector?
Perfect
what
question,
is allowed
because
and
that's the
what
next.
not?
Yeah, perfect question. That's the next thing I want to talk about. Thank you. Of course, you can imagine in a big cluster, you have tons of rules then to restrict or to allow what is actually allowed to happen. And writing a lot of firewall rules and process execution rules manually is not fun. And there, NeuVector can help by having an automated behavioral learning mechanism so that you don't have to write everything by hand. You can, but you don't have to. How does it work? In NeuVector, you can run either your whole cluster or individual containers and pods or a group of pods in different modes. The first mode is the so-called discover mode. If a pod is in discover mode, NeuVector learns the current behavior and builds up a rule set based on that. So it sees all the network connections, all the file access, all the process execution, and builds up a rule set for you. Of course, you can then review this rule set, you can manually add rules, you can remove rules, and you can export these rules as infrastructure as in security as code, and then transport them to a non-trusted system, for example. Once you're happy with the rules, you can either switch individual workloads or the complete cluster to either the monitor mode. In monitor mode, NeuVector stops learning new rules, and every time something happens that is not covered by rules, like a process execution, a network connection, or file access, it still works. Nothing is blocked, nothing breaks, but you'll get an alert. And then, probably when you don't see any alerts anymore, no false positives, you can then also switch the whole system or individual pods into protect mode. And there, NeuVector also stops learning new rules. But if now something is happening that is not covered by rules, then you get an alert. And also the network connection, the process execution, or the file access is completely blocked. And I would say, let's actually have a look at this. Because I can talk a lot, and I also want to show you quickly how this works. So what I prepared here is a Kubernetes cluster. In this case, it's running in the Rancher Kubernetes management platform, but Rancher is not a dependency for NeuVector. It's just where I have my Kubernetes cluster and how I manage it. NeuVector runs on any Kubernetes cluster, on any Kubernetes distribution. I already have NeuVector installed as a Helm chart, and because I'm running it in Rancher, it's already directly also linked here, so I can quickly access the NeuVector UI. But again, it works in every and any Kubernetes cluster. Let's look at the first thing, all the scan results of the supply chain security part of NeuVector. You can find this here on the left side under Assets. And NeuVector not only scans your container images, it also tells you, are there any CVEs in your current Kubernetes version? Here we are fine. It also scans all the nodes of your cluster and tells you, are there any CVEs on the packages that are installed on the node? And I specifically used in a very old OS image here so that we see something red, and you can see tons of CVEs and tons of packages. You can see the involved package, the version involved, if there is a fix for it or not. Of course, the severity and the severity score. And you can, of course, also click on every CVE to get more details and even get to the CVE source. here to make a judgment. Is this something where you need to do something right now, or is this maybe something that can wait until the next patch run? Next to CVEs and vulnerabilities, you also have compliance checks. These check if your nodes and your Kubernetes cluster on it is actually configured to be in accordance to best practices. The same thing you also have for all your containers that are running inside of your Kubernetes cluster. So these are all the pods that are really live at the moment. And you can filter through them. And there's, for example, some recommendation service running here for some online shop. You can see this pod has two containers, an Istio proxy container and the actual application container. And for every container, you have some metadata and some meta information, and also a list of all the CVEs inside of this container image and all the compliance issues. For example, compliance issues here would be you have passwords stored inside of the container image, or in this case, the permissions in the container file system are way too broad. So what can we do about this? You can see there is a recommendation service with lots of CVEs. How can we protect this? You can do this here under policy, and you have basically a very similar view of your cluster. These are, again, all the applications running in your cluster, including our recommendation service. And you can see here, our recommendation service is currently in discover mode. That means currently NeuVector learns the current behavior and builds up a rule set automatically. You can also switch the mode here. So you can change it, for example, to monitor or protect mode. We'll do this later. Down here in the details, you can see all the process profile rules that have been learned, or also all the network rules that have been learned. So, for example, you can see there is the front end that talks with the recommendation service, or there is Prometheus that talks with a recommendation service to get some metrics. The nodes talk with the recommendation service for health checks, or there is a recommendation service that talks to the product catalog service, and so on. You can also see that NeuVector detected in a lot of cases which protocol is being spoken on this connection if it is a single protocol. Let's maybe try to do something new inside of the container to see the learning in action. So I'm going back here to Rancher, just because it's faster and I don't have to use the command line. And let's check for the recommendation service in here. And I'm just gonna execute a shell. This is basically running kubectl exec inside of the container. And let's just run a command there, for example, a wget to google.com. And it works. I can run wget, and I also can connect to google.com and download, in this case, the index.html file. So let's see what changed in NeuVector. If we refresh this here, we can see there is now a new process rule that you can see that just now wget has been learned. And we also should see there is now a new network connection rule that also just has been learned from the recommendation service to an external system, in this case, google.com. Let's switch this now to monitor mode. So I'm switching now just the recommendation service. I'm touching nothing else in my cluster. And let's maybe remove the rule to allow wget, because that was debugging. We actually don't want to have this inside of our learned rules. And if you now go back to our container and execute the same command again, it still works. We are in protect mode. But if you now go to our notifications, we can see there is now a new security event that wget was executed in our recommendation service. So let's maybe not only alert, but maybe also block. So I'm going back to our recommendation service here, and I'm switching now the mode to protect. And if I do the same thing again, you can see now I can't even execute wget. The process operation execution is directly cancelled and blocked. And if I go back to my security notifications, I can see I got an alert again, which is now critical because the execution of wget has been blocked in the recommendation service. I can also quickly say, oh, this was actually an error and wget is really necessary for my application to work. So let's quickly re-add the rule to allow wget. And on the other hand, let's maybe remove the network rule that the recommendation service is allowed to actually connect to external systems, to google.com. So here it is. This is the rule set. So let's maybe delete this. And let's save our network rules to apply the change. And now, if I again execute the same command, I can execute wget again because I specifically manually allowed this, but now the connection to the external system actually hangs. And we can cancel this. This will run into any kind of timeout that is pre-configured in wget. And in our notifications, we can see now, okay, there is actually has been a network connections that has been blocked and that hasn't been expected. We can also see the state of our whole system not only in a list, but also in a nice network activity graph and visualize all the connections between all our applications in the clusters a lot nicer. It takes a minute to load, but here you can see lots of things happening actually. Every one of these circles is actually a workload inside of our cluster, and then all the lines are lines of communication between them. Let's filter maybe for the shop namespace, and this is a namespace where our recommendation service is in, to make this a bit smaller. You can still see it's a typical microservice application. There's tons of stuff happening here, tons of lines of communication. But you can see here on the top, this is our recommendation service. It's actually green because it's in protect mode. All the other ones are currently in discover mode. So also you have a quick view and you can see very quickly what is protected and what's not. You can also see with this red bubble here that all our applications inside of this namespace actually have CVEs but one. And you can see lots of lines of communication, including a red line. And this red line is actually the request to google.com that was just blocked. So you can also see the connection details in here. This graph also allows you to quickly change things, like, for example, change the mode or directly quarantine a pod so that it doesn't receive any incoming or outgoing network connections anymore. During the slides, I said that NeuVector also looks at the package contents. And one side effect that is really nice, actually, and a nice additional feature of NeuVector is that NeuVector can also do packet captures quite easily because of that. So for example, here I can say I want to create now a packet capture of all the traffic coming in and going out of the recommendation service. I have a load generator in the background that just does stuff there. And once I'm happy and have captured enough traffic, I can generate myself a download link and I'll get a pcap file format. And this is a standardized format to visualize and store traffic. And I can open this, for example, with tools like Wireshark, this screen here, like Wireshark, to then see, okay, what are all the connections being made? What are all the TCP packages? And through that, I'm then actually being able to debug what exactly happened and why and how. Once this is loaded, here you can see all the TCP connections. You can see HTTP request at some point, TLS packages. Here you can see a health check request and so on. This was a quick overview of NeuVector, and there's even tons of things we haven't covered. We haven't looked at all the different notifications. You get also notifications if a CVE is being discovered or if someone changes something in the configuration. And of course, these notifications you can also send to external systems. We haven't looked at the admission control system to restrict which containers actually can be created and deployed to your cluster. We also didn't look at the web application firewall and data loss prevention to scan your traffic, for example, for cross-site scripting, log4shell, SQL injections, and a lot of other network attacks that you can then activate on each connection individually. We also didn't look at CI/CD integration, registry integration, or automation of the whole systems, or even a multi-cluster environment. So there's tons of more to discover, but I hope I could get you a bit excited about container security, and I could show you how easy it is to get started, because you just have to install the Helm chart. It's open source, so there is nothing stopping you from making your Kubernetes clusters more secure also during runtime.
So, but you need a very good insight of Kubernetes clusters to use it in the open source way, I think. But it's great that you open sourced the whole package. I very like this.
Yeah, we're an open source company. Everything we do is open source since 30 years, so it's in our DNA.
Yes, just it's also kind of monitoring the security state of the clusters. I think. Do you have or is there a possibility to integrate any other monitoring tools, or do get the bigger view and not changing all the tools every time?
Yes, it is. There's, for example, an exporter for Prometheus, so that you can export all the data from NeuVector into Prometheus, build up alerts on it, build up Grafana dashboards on it, so that you also have all the data there. There's also a syslog connection, so that you can all the events and all the logs, for example, in your Elasticsearch or in your logging system or wherever you want to have security logs. And you can also hook it up to things like Slack, Teams to get all the alerts in the Slack channel. There are multiple integration options.
Great. So, and if anybody has questions or wants to learn about the NeuVector even more, they will contact you, I think. No,
Yep.
no. Or do you? Yeah, thank you.
Yeah.
That's right.
So this may be the
I
first
just want to
starting
ask.
point. I just put on some links, product page for NeuVector, product page for Rancher, then the company page for SUSE. And of course, the documentation is also open source at open-docs.neuvector.com, which has all the information for you, how to install it, how to get started, and about all the functionality of NeuVector. And of course, also feel free to reach out to me personally, for example, on social media. I'm easy to find on Twitter or LinkedIn or other social media sites.
And the community is also there,
Yeah.
so they can, everybody can reach out to the community and learn about more, and maybe contribute themselves. So
yeah, the source code is also open source, and I actually forgot one link now that you said community. So let me maybe quickly add this, like changing slides while you are speaking. Hey. Because you said community, and then I just remembered I forgot something. So there is also a Slack channel that is public, where you can just sign up at slack.rancher.io. And let's hope actually that this was correct. So let's maybe quickly try it, because I'm unsure. So you can freely sign up there, and it's a community channel. So there are lots of users here, and there's a dedicated channel then also for NeuVector. There are also engineers, and I'm on there. So it's also maybe a good point to exchange yourself with others using Rancher or using NeuVector or using our products.
great. So very thank you for the first insight and the overview, and yeah, all the possibility NeuVector is offering, and securing the clusters. So yeah, thank you for your time. Thank you for the 3 topics you covered. It was a pleasure.
Same for me. Thanks for having me.
Thank you very much. Now we got a very comprehensive overview about Kubernetes security, about the tools out there, and NeuVector, who is helping securing Kubernetes clusters and makes monitoring the security way more easy, I believe. Thank you for listening, and goodbye.